Good evening to everyone. Myself, Chirag Parikh. I'm working as a certification specialist at Amazon Web Services. Today, I would like to discuss about integrating the predictive compliance and the high voltage safety monitoring in AI-based power system for the data center. Let's discuss the agenda. In the agenda, we will discuss the overview, then the interview and the introduction and the problem. And we'll go discuss the motivation, then the framework overview. Fifth topic will be the predictive compliance engine. Then we will discuss about the high voltage monitoring system because our main topic is connected with the predictive compliance engine and high voltage monitoring system. So item number 5 and 6 are the most important. And then we'll discuss about the digital twin integration, use cases, and the standard netting, the benefit and the challenges. We are approaching different kind of approach, right? But definitely there are some benefits, some challenges, but if we solve properly, then we will get the more benefit versus the challenges. And then we'll discuss about the confusion. So first of all, I would like to discuss that what is the AI ML. In today's world, everyone is talking about AI ML if they are from any industry, if they are from healthcare or they are from mechanical engineer, electrical engineer, IT, everyone is using AI ML, right? So just I would like to discuss few minutes regarding the what is the AI ML first of all. So AI is artificial intelligence. So if I can explain you in just few sentence. So artificial intelligence is teaching computer to think and act like a smart, like human. That is the artificial intelligence. And machine learning is a part of AI where computer learn from data and improve by themselves without being told every step. So that is machine learning. And if I can give you the example, if AI is like a teaching a child to be a smart, and the machine learning is like letting the child learn by practicing and gaining the experience. So this is a AI. Important thing is when AI and ML merge together, and if we implement artificial intelligence and machine learning in our profile, then only it will help, or in our projects. So that is the AI ML. Now let's discuss about the overview. For this topic, we do have few challenges like continuous compliance in the AI-driven high voltage data center. But we do have a solution, and because of the solution, we have more benefits. So let's discuss in more detail what is the challenge. So AI-driven data center operate with complex high voltage power system that must continuously meet strict safety and regulatory requirement. Traditional compliance check are periodic and reactive, which leaves gap where the risk can build up. And that's why we have a solution. Solution is to merge the both things, predictive compliance and real-time high voltage monitoring. By combining, now let me explain you what is predictive compliance, because my title is talking about the predictive compliance and high voltage monitoring, right? So predictive compliance is AI model that anticipate regulatory and safety risks before they occur with real-time high voltage monitoring. And what is real-time high voltage monitoring? Words is explaining what is the meaning, right? Like real time, you can measure the voltage real time by measuring from the HDML or any of your device. So when we merge both things, it will work very phenomenal. And because of that reason, we do have a benefits that reduce the downtime and learn safety and regulatory alignment. Now, let's talk about the introduction and the problem statement. So AI workload and the power density increase the risk. So how it is increasing the risk? The reason is AI workload demand massive computational power, which drive up power density in the modern data center. As voltage and current load increase, so the risk is high. Why voltage and current load is increasing? Because in the AI ML, if we use the latest equipment, right, and artificial intelligence plus machine learning, and when we are using this small component. Like in the data center, there are many components. You can say server, router, switch, everything, right? And when we are implementing AI ML, the power is increased. When power is increased, that means current is more, and current is more, power is more, so there are more risk. In the traditional compliance, conventional approach like periodic audits, they what they don't in earlier they don't monitor the whole data center 24/7. What they do based on their SOP, they just go and check weekly basis. Some component need to check monthly, or sometimes they just check it out at the time of uh, when they do the cycle repeating, or when they shut down the whole plant. At the time they just make sure that all equipment are running well. So traditional compliance was very risky, and because of that reason, many times we saw that something happened in the plant don't know, and it is very hard to figure it out. But if we are using this AI ML system, right, and also monitoring the temperature, voltage, current, everything, then we can prevent any occurrence. Like if something going to happen, for example, if temperature is increasing, if you are using some AIML system, that system can warn you that, hey, your temperature is limit is 90 degrees C, but now it is more than 95, 100. And if we set up some setting in the system that if it is more than 100, it can cut down the system automatically. There are some disadvantages that our plant can stop for a while, but we can prevent some big damage in the data center, and that damage can lose the data and anything. So just wanted to give you the background. Now let's talk about the motivational. Traditional compliance is static and reactive. Most compliance today follow the checklist, as I told you, right? We do have a checklist. We just need to make sure that we are following those process. Audit happen at fixed interval. Rules are applied after system are deployed, and issue are usually discovered only when something goes wrong, or when an external audit occurs. In dynamic AI-driven environments need proactive approach, because we can't wait till something wrong happen. That's why they are saying that in dynamic AI-driven environment, we need a proactive approach. Now I do have a framework. You can see overview here. This is a data acquisition layer, voltage, current, temperature, fault. Second layer is a compliance integration engine. So in earlier data center, what happened? This step was not there. Second step was also not there. And because of that reason, we can get any result. That reason can be the positive 90% of time. But because of this stage two layer was not there, so we can't say that our data center or system is running 100% safe. But now we added compliance intelligence engine and high voltage monitoring subsystem. So we can track our whole system 24/7. Now let's talk about the predictive compliance engine. So compliance rule integrations, UL/IC standards. So these are the standards for the certification. Like if we need to approve our product, and if we would like to sell our product in the market. So based on the market, we have a different standard. For example, for US, we are using the US standard. For Australia, we are using AZ standard, and IEC standard is used for the Europe. But just wanted to discuss little bit more on this standard. These standard are actually connected, or we can say harmonized with each other. So what happened? We have a data center, right? In the data center, we have different kind of equipment. But if we certify our equipment or whole data center equipment with IC standard, then 90% of case we are good. The reason is each standard is harmonized with the different standard. I can say if our product is harmonized with the IC standard, then we can ship in the Australia as well, all US as well, and Canada as well. But some of the country has a different requirement. 80% of standard are same, but 20% is different. So we need to do the gap analysis and need to perform additional testing as well if it is required. Now let's talk about how high voltage monitoring system. As I told you, voltage is high. So so there is a formula. We know that P equal to VI or P equal to VI cos phi. So how power is more, if voltage is more or current is more, you can get the power is more. In our data center, normally current is more, and because of that reason, power is really high. And if we are using the AIML data center, then the power, one data center power are in kilowatts. So basically the power is really high. Because of that reason, arc detection and partial discharge is can be happen, and we have to monitor that part. Also, when the power is more, temperature can go really high. So we need to measure the temperature as well. And the important thing is only measurement is not important, but we need to track real time integration with the compliance engine. So what happens if temperature is high and if we integrate it with the compliance engine, it can cut the power. It can make the decision right away. We don't need to think manually that what is the next step. Can we stop the machine or how it will impact the ML machine learning? It will work automatically. They don't ask anything. They just stop the system, or they can find the different path for the cool down. For example, if temperature is more, you know that when we are working on the laptop, right? Sometimes the fan is running like very slow speed. That's why the you can't get any noise. But if you have multiple application open in your laptop, right, and it is running since last 15 hours or 24 hours, sometimes you can see that your fan is really active and you can hear that noise. What is that doing? They're just the temperature is high and they are getting signal that, hey, my component internal component temperature is high, we need to lower down the temperature, and that signal go to the fan, and fan is running on the high speed. And again, when the overall temperature is low, the system is getting signal, so fan basically get the signal, and speed can again reduce automatically. So everything is working on the same way basically. Now we do have some use cases. For example, rack level. So PDU is mainly for the load balancing and overcurrent detection. UPS system, it is for the battery backup. We know that predictive inverter battery failure. When something happen, UPS can turn on automatically. Switchgear and the busways. So arc flash hazard detection and AI load management, safe automation control. Food point is really important. They can manage the load as well, like based on the priority in the system. In the data center, what happened, we do have a backup as well. Like if something is not working, it can move to the directly the second system. In the server, if one of the power supply, we have a charger, right, for the laptop. Just assume that if one charger is not working, it is automatically bypass the first one and connect with the second one. So we do have backup in the data center. Now, a few minutes back, I was talking about IC standard, right? So these are the few standard that also need to comply with our data center or the specifically critical component list of each equipment. For example, 61010, that is for the voltage insulation, electric shock protection, can covered by this standard. Same as a UL 62368-1, that is hazard-based approach, and 61010, these are the basically standard, and they are saying that, for example, controller and overcurrent protection, how it is covering and certifying with these standards. Now let's talk about some benefit, challenge, and outlook. So there are very too many benefits. First benefit is minimize downtime, enhance the reliability. Second benefit is real-time compliance enforcement. Fourth benefit is data-driven maintenance and safe operation. And the fourth benefit is audit-ready compliance snapshot, because it is recording all the data 24/7, right? So we don't need to create a data that, oh, yesterday it was running with this temperature, and because of that reason it moved from one operation to the second operation. So these are the benefit, these are most four benefit. We have many more, and the challenges are integration with legacy infrastructure. We need to change some of the infrastructure. by changing this system. Then complexity in the cross-specific model training, and future I can say is only AI plus digital twin as a compliance standard. Now I would like to discuss the conclusion, what we are concluding here, that earlier, without AI/ML, everything was working well, but now using the AI/ML, we increase the power, we increase the efficiency, accuracy is more, we can avoid some hazards happening. So first conclusion is predictive compliance plus high voltage. If you use only predictive compliance, definitely you will get some benefit. If you use only high voltage monitoring, right, then also you will get benefit. But if you combine both things, then it is the most benefit for the future and therefore the data center. Static audit give way to the continuous proactive intelligent compliance, and compliance is no more a barrier. It is a strategic pillar of AI/ML infrastructure development. So why I'm saying this last sentence and I just bolded that line, because people are thinking that we have a data center or any component. No, I'm not talking about only data center, but anything, like if you talk about the mobile, laptop, any electronic, when they manufacture won't like to sell in the market, they are thinking that, oh, we need to comply with this standard. But that is not a burden. It is actually, if you plan properly, if you design your product based on the standard, then it is your pillar, because you don't need to worry. If you, I know the market where I would like to sell my component, right? Then what I can do, I can do the testing, I can create a product such a way that I can ship anywhere without any issue. And why I'm saying it is a pillar, because after launch we don't need to worry, because we do have a reports, we do have all compliance reports, and we know that our product is very safe to use. So that is my conclusion. Yeah, thank you so much for your time.